Hi, this is our second video on our analytic geometry or pre-calculus journey, and this one is on what are called linear equations. That is basically the equations that relate to a line. Linear, linear. I'm expecting that if you're watching this video and you're in a analytic geometry or pre-calculus course, you've probably already seen this before. Although nothing will prohibit you from watching this if you're in algebra or geometry too. But anyway, linear equations, equations of a line. Basically, these are first-degree equations. What I mean by that is they're not equations with an x squared in them. They're not equations with a y squared in them. They're not equations with an x cubed. They're not even equations where an x is times a y, xy. There's nothing like that in these. These are equations where there's an x and there's a y. Or they're just two variables, and they're in the first degree, which means that we don't usually write the 1 when you talk about x to the first power, because x to the first power is just x. And so that x on the screen there is an x to the first power, and that's what I mean by saying they are first degree equations. They are only equations with x's and y's that are not to a second power or third power, and they're not times each other. It's just an x and a y, an equation in two variables. There are different ways to put the form of a linear equation, and these different forms is basically what this video is about. Different forms help you get at different problems, but basically to overview the forms we're going to look at in this video. So there is the standard or general form, ax plus by plus c equals 0. That's just the general form of a line. A and b are called coefficients, c is a constant, and then x and y are the variables, if you want to know the lingo, algebra kind of lingo. Much more interesting, and hopefully you've seen before, is the y equals mx plus b form. This is sometimes called the slope-intercept form, because the b tells you where it crosses the y-axis, and the m tells you the slope, or the slant. So it's very convenient, very convenient. Okay. There are other forms, two other forms that are mentioned in this video. One of them is the point slope form, y minus y1 equals m times x minus x1. It's called the point slope form because it allows you to find the equation of a line if you just know a point and the slope being the m again, and then x1, y1 being the point. Remember that the way we conventionally tell you a point is we put two numbers in parentheses. The first one is usually the x, comma, and then the second one is usually the y, and that's how we standardly tell you about a point. Okay, well those are the basic ones. There's one more that we're going to talk about in this video. So let's start with the slope-intercept form. Y equals mx plus b. So the b is the y-intercept. If you put a line equation into this format, the b tells you exactly where the line, however it's going, crosses this y-axis. And that makes sense because where does a line cross the y-axis? Well, it crosses the y-axis when x equals 0. And so if you put in 0 for x here, the mx goes away because anything times 0 is 0. And we're basically left with the point where y equals something, where it crosses the y-axis. So this makes sense because y equals b when x equals 0. So the b tells you where the y-intercept is. Okay, if m is the slope then it's telling us the slant of the line. And you might remember that we call the slant of the line the rise over the run. That is how much it goes up divided by how much it goes over, or up and over, or down and over. They can be negative and be down, or negative and go to the left. So anyway, the rise over the run is the slope. Y2 minus y1 divided by x2 minus x1. If you have 2 points, a x1, y1 and a x2, y2, if you take the y's and divide them by the x's, doesn't really matter which order you do them in, it'll come out the same. You're going to get the slope, or the slant. Just to make things complicated, here's a little diagram I drew. You can see here the rise is the up and down part, and the run is the side to side part. So if you have 2 points, an x1, a y1, and an x2 and an y2, then if you divide the rise, say y2 minus y1, by the run, say x2 minus x1, that gives you the slope. And then just for free, I threw in a supposed y-intercept here. You can see where x equals 0, then b is going to be where the line crosses the y-axis. That's called the y-intercept. Well, I hope that diagram doesn't completely confuse you. Okay, so let's go to that. So we talked about the slope-intercept form. Here's the point-slope form. The point-slope form allows you to derive an equation for a line when you know one point, x1, y1, and the slope. So the y and the x here you leave there. You plug in x1, y1, the point, and you plug in the slope, and then you have basically the raw material to be able to rearrange it into slope-intercept form or to rearrange it into whatever form you want. But this is another way of laying out the equation for a line so that you can figure out the equation for a line when all you have is a point and the slope. Here's something called the two-point form. This is when you don't know the slope, but you know what 2 points. 2 points make a line, right? And so you have all the data you need to come up with the equation of a line if you have 2 points. So again, if the points are x1, y1, and x1, y1, and x2, y2, just plug it in. You can see that y2 minus y1 over x2 minus x1, that's the slope. That's the m anyway. And then the rest of it's just basically the point-slope form. So you can use this two-point form. It allows you to come up with the equation for a line when you have 2 points, but you don't know the slope. Okay, lastly, it's worth saying something about parallel and perpendicular lines. Parallel lines, no matter which way they're going, are going to have the same slope, right? They're parallel, so their slope is going to be exactly the same. And so parallel lines always have the same slope. Perpendicular lines, those are lines that are 90-degree angles to each other, are going to have the opposite and the reciprocal slope. The opposite reciprocal. What does that look like? Perpendicular lines will have a slope that is the opposite reciprocal. Well, what does that look like? If the slope of a first line is A, that's A, not is A, that's a, it's a, first line is A, then the slope of the perpendicular will be the opposite reciprocal. So opposite means negative, and then reciprocal means you flip it. You put a 1 over it. So the reciprocal of A is 1 over A, and the opposite is negative. So if the slope of the first line is A, then the slope of a perpendicular to it is going to be negative 1 over A. There you have it. Hopefully some just review of linear equations.